Learners, in today's lesson, we're going to be looking at functions, the parabola function, the hyperbola function, and also the linear function. And let's see what we've got. We have question 4. It says, given h of x is equals to negative 3 over x minus 1 plus 2, we are required to write down the equation of the asymptote of h. But if we can do just a small revision on that, ne? So let's do a small revision on the hyperbola function. So when you are given something like this, y is equals to a over x minus p plus q, you must know that you are now dealing with what? A hyperbola function, right? This is a hyperbola function. Then what must you know? You must know that x equal to p is your what? Is your vertical asymptote. This is your vertical asymptote. So what is an asymptote? An asymptote is a point on a graph where it's a point on the Cartesian plane where your graph doesn't touch, right? Then what is q? So your y equals to q will be your horizontal asymptote. Will be your horizontal asymptote. So with the vertical asymptote, the trick is every time you are given this and then you are asked to give the equation of the vertical asymptote, you must take whatever that's in here. So for example, x minus p, then equate it to 0, then transpose the p here, whether it's a negative or positive, transpose the p, then you have your equation as x is equals to p, which is your vertical asymptote. So always with this one, when calculating the vertical asymptote, you must take whatever that's in your denominator, equate it to 0, then express your x as the subject of the formula. In doing so, you have calculated your vertical asymptote. But when it comes to the horizontal asymptote, you just take the number that's going to be at the position of q the way it is, right? So that will be your horizontal asymptote. Then we are left with what? A. What is A in this case? A determines the wideness, the shape, or the position of the graph. So what do I mean by wideness? So you'd get that there is a variance when your A is bigger or smaller. So you find that at times your graph might be a little bit wide, at times it might be narrow, and then that also affects its shape. Then what do I mean by the position? So by the position, I'm only saying if your A is greater than 0, then your graphs tends to be on the first quadrant and the third quadrant, right? So if this is my mother graph whereby my y is equals to 0 and my x is equals to 0 here, being your vertical and horizontal asymptote. So this is your horizontal asymptote and this is your vertical asymptote. That means they do not touch the y-axis and the x-axis. So if your a is greater than 0, you will normally have your graph like this, right? So whereby it is located in the first and the third quadrant. What about if now you have a being less than 0, meaning your a is negative. Here your a is positive. Now if your a is negative, then you will have your graph being located on the second and fourth quadrant, right? So you have the second, you have the fourth quadrant here, right? And then still your x is equals to 0 and your y is equals to 0 are your asymptote. Remember, this is the mother graph, right? So when your a is less than 0, meaning it's negative, we expect that when you draw, we will locate your graphs to be on the second and fourth quadrant. But remember, this is one graph. They just appear in two quadrants, right? Because that's the nature of that, or of a hyperbola. It is two asymptotes that divide the two wings of the same graph, right? Then that's it. Now let's see if we can answer the questions here, right? It says 4.1.1, write down the equation of the asymptote of H. Now that we are filled with that knowledge of how to identify the asymptotes, then what are we going to do now? So we're going to go x minus, what do we have? Minus 1 is equals to 0. So we're going to have x is equals to 1. This is now our vertical asymptote, right? So you're not required to tell us which one is the vertical or horizontal asymptote, but then it is crucial that you know when it comes to sketching, right? Then what's our horizontal asymptote? What is our y? Our y is just 2, right? So this will be our horizontal asymptote. Now you have your two equations of the asymptotes. Always in a hyperbola graph, you have two asymptotes, the vertical asymptote and the horizontal asymptote, right? So that's it. You can see it. Then it says 4.1.2, determine the equation of the axis of symmetry. So what are we talking about when we say axis of symmetry? The axis of symmetry is the line that divides the two wings of this graph into like two equal parts, right? So it's like a mirror that if you put it there, it would make the two divide into two equal halves, right? Then determine the equations of the axis of symmetry of H that has a negative gradient. How do you determine the one that has a negative gradient? So let's come here. So I have my equation like this, and whenever you are determining the equation, the equation of the axis of symmetry, it's just a matter of taking the numerator here, add it with the q there, right? Like that. So but then when they say, so this one, if they said for the positive, you just take y is equals to x minus 1 plus 2. Then you'd have x negative 1 plus 2 is 1. But then now they said they want the axis of symmetry with a negative, right? With the negative. That means this is the line, when you draw it, it would go something like this, right? The negative. So now if they say the negative, is just a matter of taking the very same thing, but then right now you put a negative before whatever that's in your denominator here. So x minus 1 plus 2, right? Then now we have y is equals to negative times x is negative x. Then negative times 1 is positive 1 plus the 2. Then you have y is equals to negative x plus 3. Now this is your correct answer. This is how you calculate the axis of symmetry of a hyperbola that has a negative gradient. So you just come here, put the negative gradient as they wanted, then you calculate. So don't forget what's on your denominator, you have to put inside the brackets, right? Then we have sketched the graph of H showing the asymptotes and the intercept with the axis. So the first thing you want to identify here is what will be the shape of the graph, your A. So now you can see that your A is negative 3. Now we know that if we have a negative for our graph of the hyperbola, our graph will be located on the second and fourth. So we already have the shape. So that's what they're gonna mark. We already know the shape, right? Now it's time. The first thing you wanna do is you wanna draw the Cartesian plane, and then before you do anything else, fill in your asymptotes, right? Fill in your asymptotes. So this is how you're gonna do it. And then you go. So what are your asymptotes? You have, so let me just use a different color for the asymptotes. You have x is equals to 1, which is the vertical asymptote. So you can see it crosses the x-axis like that. So this is x is equals to 1. So always your vertical asymptote are represented by x. They cross through the x-axis. Then here you have your horizontal asymptote, which is y is equals to 2. It crosses the what? The y-axis, right? Then, now that you know that you have that, now that you have drawn your asymptote, right? The question says it also wants you to show the intercept with the graph, right? So how do you show the intercept with the graph? Now you have to calculate. We know the intercepts are your x-intercept and your y-intercept. This is where you have to come calculate the y-intercept. So on the side, you just calculate y-intercept, right? Then you come, here's your equation. You have negative 3x plus x minus 1. X minus 1 plus 2. So to calculate the y-intercept, it's easy. You just make x 0, right? So now you have 1 here plus 2. So if you punch that, or if you punch that in your calculator, it's going to give you 5. So your y-intercept is 0 is to 5. Now coming to the calculation of the x-intercept, you have to now make y 0. So we have negative 3 x minus 1 plus 2, and your y is 0, so it's going to be negative 3x minus 1 is equals to negative 2. Then negative 3 is equals to negative 2x plus 2. So if you just cross multiply the x minus 1 with the negative 2, so negative 2 times x is negative 2x, negative 1 times negative 2 is positive 2. Then what do you do here? You can just transpose the positive 2 to this side. Is going to be negative 5 divided by is equals to negative 2x. So we're going to divide by negative 2, divide by negative 2. Then what's our answer here? We'll have x is equals to x is equals to positive 5 over 2. So this is your y-intercept. 5 over 2 is 20, which is like 2,5, right? 2,5 is 20. So you come here. Now that you have your intercept, this is your y-intercept. Your y-intercept will always intersect with the y-axis, right? Then you join it here. So remember, this is the asymptote. It doesn't have to touch the asymptote, right? Then you also have somewhere here your 5 over 2. So you're going to join it here. So pardon me if my graphs don't look that much neat. So here we have 5 over 2. And then here we have 5. So remember, this is a sketch. You don't have to be accurate with your points, right? So that is to say, you don't have to necessarily draw it to scale. You just need to show us the important points, which are the vertical asymptote, the horizontal asymptote, and the intercept with the axis. This is what we want to see. Then as the final touch, you can just label your graph. This is h of x, right? And then you are done. So when you draw it, when you sketch it nicely, but then you don't have to be precise with the points, right? Then we have 4.2. It says the graph of f of x is equals to 1 over 2x plus 5 square minus 8, and g of x is equals to half x plus 9 over 2. So a sketch below, you can see from our equations there that f of x is obviously our parabola, even from the sketch, and then our g of x is a straight line graph. Then point A says A is the turning point of f, right? We can see that A is the turning point here. Then point number 2, it says the axis of symmetry of f intersect the x-axis at E, right? So it intersect with the x-axis at what? At E. So where's the axis of symmetry? The axis of symmetry of what? Of f. So intersects where? At E. We can see that it intersects with the x-axis at E, meaning that our E is now an x-intercept. And the line G at D, M and N. So it intersects with the line of G, right, at D. Then C is the y-intercept of F and G. So we can see C being the y-intercept of F and G, and also being the point of intersection between F and G, right? So we have 4.2.1 says write down the coordinates of A. Now again, quick revision of the parabola graph. So if you are given a parabola graph in this form, x minus then square plus q, so it can be a plus or minus here. Then if you are given in this form, you have to know your x minus p equal to 0, then your x is equals to p. This will be your x coordinate. This will be your x coordinate of the turning point. So when you are given like this, we call this the turning point form, right? So, or we can say it's the completed square form. So in this way, we have completed the square. So we can call it the turning point form or the completed square form, right? So this is the x coordinate of the turning point, and q, y is equals to y equals to q will be the y coordinate of the turning point, right? Your y coordinate of the turning point. So you can see the difference with this one. We were using the same letters p and q also for the hyperbola, but they don't mean the same. For the hyperbola, the p was just the vertical asymptote and q the horizontal asymptote. Here the p is the x coordinate of the turning point, and your y is the y coordinate of the turning point. So now how do you get that one? So you can see with the x, the same thing is happening here. Before you can tell us the x coordinate of the turning point, you are supposed to take whatever that's inside this bracket, equate it to 0, then you make x the subject of the formula. In that way, you will have found the x coordinate of the turning point. Let's see how that one applies in context of the question. Right, so we have write down the coordinates of A. So the coordinates of A in this case will be what? So I have, writing my equation of f of x, I have half x plus 5 square minus 8. Now I know I have to take this one for the x coordinate. X plus 5 is equals to 0. Then calculate my x. It's going to be negative 5. So that's my x coordinate for A. And then what's my y coordinate for A? I just take the q as it is, right? So it's negative 8. So my A is negative 5 is to negative 8. Let's check with context of the graph. We can see that our A is on the third quadrant here, right? So this is the third quadrant, whereby we know that our A will be, our x coordinate will be a negative and our y coordinate will be a negative. So yes, A is negative 5 is to negative 8. Then 4.2.2 says write down the range of f. When we speak of range, what are we speaking of? So the range is a set of all, a set of all possible y values. So sikhuluma ngawo wonke ama-y values that will exist in this graph, for which the graph will exist. All the y values for which the graph will exist, right? So if we can check here, we are checking in terms of the x values. So that means we are checking in context of the y values. I mean, that means we'll only be looking at the horizontal movement. Remember, your y here, we'll be looking in terms of the vertical movement. Sorry for that. We'll be looking in terms of the vertical movement. Remember, your y is going vertically up and down, right? So if you can check here, you can see all the way down here, you don't have the graph of f. All the way down here, you don't have the graph of f. You don't have the graph of f. You don't have the graph of f. Remember, we are going upward with this, right? Now, starting from here, at this point A, this is where the graph of f starts to exist, right? This is where now we have the graph of x being recorded, right, at A. What's that point there in terms of your y values? In terms of your y values, the point at A is -8. And then you can see that all the way through we will have values for y. We will have values for y because the graph of f is existing all the way. Then what happens here? This is not where the graph of f stops. Actually, you see the arrows here. The arrows indicate that there is a continuation of the graph. So the graph can go all the way to positive infinity, all the way up to heaven and pass through that heaven and whatever, right? So it will start from -8 all the way up to positive infinity. Now, how do we write that in terms of the range? When you write the range, you say y is an element of what? Starting from where the graph will begin, right? So obviously we know the graph has to begin from all the way down and then going up, right? So we'll say -8. Why am I using square bracket? Because -8 is also a possible y value. Then all the way to positive infinity. But then now I use round bracket. Why? Because we don't know what is positive infinity. It can be trillion, it can be whatever. No one knows where the numbers actually end, right? So positive infinity, it can be any number that we cannot even think of, right? Or if you do not understand this one, you can just write it in this form. You say y is greater or equals to -8. What are you saying? You are saying, Guti, the graph of f will exist for all the values that are starting from -8 all the way up to whatever value that we don't know. So you are saying, Guti, the graph exists for points that are starting from -8 and that are greater than what? Than -8, right? Which is this thing, and that thing is the same thing, totally the same thing, right? So y is an element of -8 included all the way to positive infinity, and that's how you have your range. So here, just for interest's sake, if they said calculate the domain, what is the domain? The domain is a set of all possible x values, right? A set of all possible x values, right? So in this case, you can see if they say a set of all possible values, that means for x, I have to check in relation to the horizontal movement. I have to check in relation to the horizontal movement because x is moving horizontally, left to right or right to left, right? So from here we can see that all the x values are possible. So if you have to stretch this all the way, you will realize that all the x values that you can think of are there. So you will say x is an element of real numbers. So always with the parabola graph, what we know is with the parabola graph, when we are checking the domain and range, the domain will always be x, an element of real numbers. And then the range the range will go with accordance to the shape, right? So revision again. So when we are checking the domain for, it will always be x is an element of real numbers. When we are checking the range, if we have a shape like this, right, which we call it concave up, whereby your a is greater than 0, right? So this is a concave up graph. Always your range will be y, an element of the turning point. So the y coordinate, remember, the y coordinate of the turning point over is to positive infinity. If we have your a being less than 0, meaning it's a negative, we have a graph that somehow looks like this, a concave down graph, right? We will have your y being an element of negative infinity all the way to the y coordinate of the turning point, right? The y coordinate of the turning point. So always it's like that. So you can either write it y greater or equal to the y coordinate of the turning point. Then here it's y is less or equal to the y coordinate of the turning point, right? So always note it's the y coordinate of the turning point. So always it's like that. You just have to look at the shape. When the shape is concave up like that, then it's y element of the y coordinate of the turning point all the way to positive infinity. Then when it's concave down like that, it's y is an element of negative infinity all the way to the y coordinate of the turning point. So I hope you get that one. Then we have okay, 4.2.3 says calculate the values of m and n. Calculate the values of m and n. And if you can check there, you will see that they said something there about your D. They said the axis of symmetry of F intersect the x-axis at E and the line G at D, M, and N. So we do understand that D intersects. So here is the point of intersection between the axis of symmetry of F and the straight line G, right? So since we know that this is an intersection, we can obviously conclude that the x coordinate here of A, which is our turning point, is also the same x coordinate for D. You can see that they're in line there. So what is the x coordinate of A? It's -5, right? And then what will be the x coordinate of D? Obviously -5. But then you can see that the x coordinate there is equals to what? M, right? So in other words, we have found our m without even calculating, right? M is equals to -5 for the mere fact that they are in line, right? So it's -5. Now that we have -5, we can now substitute that value where? On the straight line, because D is found where? On the straight line equation. So we can substitute the -5 on our x coordinate here, on our x as our x value, then we get the y, right? So first of all, we have D given as m to n, but then m is equals to -5, right? Then now the equation for g of x is equals to 1 over 2x plus 9 over 2. So to get n, which is our y, we can simply say n here, then half. Then what is my m, which is my x coordinate? It's -5 plus 9 over 2, right? Then punch that in your calculator. What are you supposed to get? So you're gonna get n is equals to 2. So if you can just punch that in your calculator, then Now you have found your m and n. Your m is -5 and your n is +2. Then they say calculate the area of OCDE. Calculate the area of OCDE. Now let's check OCDE. If we can see, OCDE is what we call a trapezium, right? So this is a trapezium. And then what do we do to calculate the trapezium? We can find the length of DE. Find the length of DE. What is the length of DE? So now since we have concluded that n is 2, and then from E it's 0, then DE, it must be 2 units. Then OC, if you can check, C, there is a y-intercept of the line GX. This is 9/2. So we know that C here will be 9/2. Why? Because the C here, y from y is equals to mx plus c. The c here is always the what? The y-intercept. And we can all agree that c is the y-intercept. So it takes the value of 9/2, right? So what is OC? What is 9/2 by calculation? If you just write it in decimal form, it's 4.5, right? From your calculator, just say 9/2, then press SD, right? Then now that we have that, we must have one side here, which is this one, OE, right? We must have OE. Then what is my OE? From O to E, it's how many units? So E is 5. So from O to E, it's 5 units. Now that you have this, if you still remember to calculate the area of the trapezium, to calculate the area, just need to say half A plus B times your perpendicular height, right? So what do we have here? It's half. Then what's my A? So one side I can have OC, another side I will have DE, right? And then my perpendicular height becomes OE, right? So what do I have here? It's half. What's my OC? 4.5 units, right? So it's 4.5 plus what's my DE? It's 2 multiplied by what? By the 5 units, right? So punch that in your calculator, see what it gives you. So it's supposed to give you 16.25 units square, right? 16.25 units square. And that's how you could have calculated the area. Or if you didn't know it was a trapezium, or you knew it was a trapezium, but then you kind of forgot the formula for the trapezium, because let's all agree trapezium is not much of a common shape, right? So it's easier to forget the area of a trapezium. You could have done it like this. So if you can see, if I can just draw out this shape here, you will see that if you cut it here, you now have two shapes being formed out of this trapezium. You have the right angle triangle, and then you have the rectangle, right? So you have the rectangle and the right angle triangle. So where will you cut it? You'll cut it from D, all the way from D to here, right? So in that form, what are you going to do here? So you'll just kind of manipulate this. So calculate the area of this right angle triangle, also calculate the area of the rectangle, then add them together in a way you would have found the area of OCDE, right? Now let's try that approach. So I was simply going to say, okay, the area of OCDE is the same OC DE is the same as me calculating the area of the rectangle plus the area of triangle, right? So what is the area of the rectangle? Those are the more common ones, so it's length times breadth. Then what is the area of the right angle triangle? Half base times height. Now we want to come here and check what is the length. The length will be the OE here, right? So the OE becomes the length, which is 5 units. Then from here, maybe you'd invert a point, say maybe we'll call it K, right? Just at the point where you made the intersection. So we'll have line DK there. So from 0 to K, or maybe you could just use this line here because it's the same length. This is a rectangle. So OK and DE are the same length according to the properties of a rectangle. So we have 5 times 2 here, then plus, what is the base? So we have half. What is the base of this rectangle here? So the base of this rectangle happens to be what? Happens to be the AK here, the AK, which is the same length as what? As the EO, right? OOE. Then we have what? Base 5, and then what do we have as the height? So the height becomes KC, right? KC. Now that we know that C is 4.5, and then here it's 2, here it's 0, so we want the length from 2 to 4.5. So we're simply going to say 4.5 minus 2, we get 2.5. So here we're going to have 2.5. So let's write it there. So what's my length? Said it's 5. Length is 5 multiplied by the breadth is 2. Then what's my base? Base is 5. And then what's my height? 2.5. Multiply all this together, we're going to have 16.25 units square. So it is still the same answer as the one that we got there, right? And then still there is another method of which I just want you to try it out on your own. You could have said, okay, let me just calculate the area of this whole triangle here. Right angle triangle. Then I'm going to subtract this small triangle here, right? So if you calculate the area of this whole purple triangle, right angle triangle, minus it or subtract the green triangle, the green small triangle, do you see what you are left with? You are left with OCDE, which is what they're looking for, right? So if you can just calculate all that, calculate this one, then subtract it, then you are also left with this one, right? So this is what you should try on your own. Then 4.2.5 says determine the equation of G prime 1, the inverse of G in the form of Y, right? So let's check now. We must calculate the inverse. But remember, whenever they say calculate the inverse, we know that the inverse is whereby we say y is equals to x. So the inverse is more like a reflection of this graph G of x in the line y is equals to x. So whenever they say the inverse, that's what you should think of. This is a reflection of the equation or the graph in the line y is equals to x. So what are we supposed to do here? So we're going to go write the original one. G of x is equals to half x plus 9 over 2. But then since we understand the inverse is y is equals to x, remember the g of x stands for y, right? So if you can just allow me to rewrite that one. So I will have y is equals to half x plus 9 over 2. Then I know y is equals to what? To x. So at this point, what must I do? I I'm going to have y is equals to half x plus 9 over 2. Then now, where there is x, I'm going to put y, and where there is y, I'm going to put x. So it's just the change in the positions of the x and y. Now, I must make y the subject of the formula, so I'll have to transpose this one to that side. X minus 9 over 2 is equals to half y. So now, having to make y the subject of the formula, I can just multiply by 2 to get rid of the half. So it's just like multiplying by the inverse. So multiply by 2 over 1. All this inside the bracket. So what do I have now? I'll have y is equals to, what is 2 times x? It's 2x. What is 2 times negative 9 over 2? It's negative 9. Now this is my equation of the inverse. Y is equals to 2x minus 9, right? 2x minus 9. That's the equation of the inverse. Now 4.2.6 says if h of x, if here h of x is equals to the inverse of g plus k is a tangent to f, determine the coordinates of the point of contact between h and f. So now they're saying if this equation that we have formulated, which is the inverse of g plus a constant of k, is a tangent to f, we must determine the coordinates of the point of contact between h and f. But then you will remember from differential calculus that at the point of contact, the two graphs will have what? The same gradient, right? So at the point of contact, the graph of what? Of h of the graph of f and the graph of h of x, which is now the newly one that has undergone an inverse, and then we have added the k to it. So the tangent at that point, or the coordinates of the tangent and that graph of f, will have the same what? Will have the same gradient. So at this point, what are we going to say? We can simply just calculate the gradient of f. So the equation of f is given as half x plus 5 square minus 8. So obviously we'll have to solve this. Then we're going to have x squared plus 10x plus 25 minus 8. Then we have half x squared plus 5x plus 25 over 2 minus 8, right? Then we're going to end up with f of x is equals to 1 over 2x squared plus 5x minus 9 over 2, right? So now we want the gradient formula for f of x. The gradient formula is obtained from f prime x. So we're going to just derive this one. 2 times half, it's going to be x, right? Then deriving that one, we're going to be left with x plus 5. So this is f prime x derived, right? So this is the derivative. Now, what is the equation that we've been given? We've been given h of x to be g prime x plus k, or the inverse of g plus k, right? Now let's write out the equation of h of x. Remember the inverse, we found it to be 2x minus 9, so it's gonna be plus k, right? Since they're saying plus k. Now if you can check, from mx plus c, y is equals to mx plus c, we can see that the gradient is what? Is 2, right? Then what did we say? The gradient at the point of intersection between f of x and the tangent will be the same. Now we already have the gradient of the tangent. So what can we do? We have the gradient equation of the parabola, which is, what did we get? X plus 5. x plus 5. Now we know f prime x must be equal to the gradient of what? Of the tangent at point of intersection. Always note that. At point of intersection. Right? So your f prime x must always be equal to the gradient of the tangent at the point of intersection. So what are we going to say now? Since we know f prime x is equal to the gradient, what is the gradient of the tangent? It's 2. Then we have x plus 5. So now the gradient of the tangent equals to the gradient of f prime x, right? Then we have x. What is our x? To calculate our x coordinate, just simply have to say 2 minus 5. Then what's our x? 2 minus 5, it's negative 3, right? Now we have found the x value of the point of contact. What must we do to get the y value? So in this case, we can either substitute in the equation of the tangent or the original, but then we cannot substitute in the equation of the tangent since we do not have k, right? So obviously we must go back to the equation of what? We must go back to the original equation of f of x, right? Then f of x is equals to half x plus 5 square minus 8. What is our x? It's negative 3. So we're going to have half negative 3 plus 5 square minus 8. Then you don't have to do a lot. Just punch that in your calculator. Then negative 6. Now what's the point of intersection? The point of intersection is negative 3 is to negative 6 in coordinate form. That's your point of intersection. And that's how you could have solved this question. Voila!